Welcome to the second mini lesson on the periodic table. During this lesson, we hope to answer the question, how is the periodic table organized? In the sense we're going to be talking about groups and periods and the three main categories of metals, metalloids, and nonmetals. So to start answering this question, we're going to be looking at it from a slightly historical point of view, very quickly, and then we're going to go really right into the core and the crux of the topic. So to start off, we're going to talk about Mendeleev. And basically, he's the one that developed the periodic table in the 1800s. And what makes it very particular is, although we know today of 118 elements, Mendeleev only had about 60 that were discovered at that time to work with. So the beauty of his table, or the development of his table, is he actually was able to leave space and predict where these elements would be and what characteristics some of these elements would be. So just to kind of understand what he did, we're going to take a much simpler sample. We're going to take the top 20 elements just to go over and kind of get an idea of what it actually took Mendeleev to piece all of this together. So here we have tiles representing the top 20 elements of the periodic table. In the center of your screen, you should be able to see a tile with the number 1 on it. This represents hydrogen with its 1 electron. If you go to the left of the screen, you're going to realize there should be a tile with the number 2. This represents the element with 2 electrons, or helium. And pretty much all the top 20 elements are represented here by tiles based on their electron configuration. Now, how we would want to organize this depends honestly on what you see as a difference. The first thing you can organize is just by simply placing them in numerical order. So saying, for example, 1 to 20, right? No harm done. But if we wanted to, we could even change that a bit. We could say, instead of that, maybe we'll put all those with 1 number in 1 row, and then those with 2 numbers the row below, and so whatnot and sort. So that we have the numerical order, but we can also place them with how many have 1 number, 2 numbers, 3 numbers, or 4 numbers. And from that, we're actually going to get something that looks like our current periodic table. So key concepts we're going to look at in this mini lesson. The periodic table regroups all known elements, now 118, based on their physical and chemical characteristics. And we're going to look at that through periods, groups. Please consider that families will be seen in the next mini lesson. And the 3 main categories of the periodic table, the metals, nonmetals, and metalloids. This is kind of a recap of what was in last mini lesson. All the elements in the same period or the same row have the same number of electron shells, and all the elements in the same column or group have the same number of valence electrons. So this is the take-home message for this mini lesson. Let's first look at periods. Periods basically correspond to the rows of the periodic table. Again, the elements in the same row are part of the same period and therefore have the same number of electron shells. Let's take a few examples. So let's take, for example, the second row of the periodic table. Well, all of these elements, because they're on the second row of the periodic table, are in the second period, and that means that they should have 2 electron shells. So if we were to draw them out, we would have lithium with its 2 shells and 3 electrons, beryllium, 4 electrons on 2 shells, boron, we're still on 2 shells, and so on and so forth until the shells basically fill up at neon. If we wanted to add an electron to get to, let's say, sodium, which is on the next row, we'd actually have to add another electron shell. So to recap periods, we're going to do this very simply and quickly. Let's take aluminum, for example. Aluminum is located on the 3rd row. Therefore, when we wish to draw it or identify it based on a drawing, we should have 3 rings around the nucleus of aluminum. Barium, for example, okay, is located on the 1, 2, 3, 4, 5, 6th row, and therefore should have 6 circles around its nucleus. Please note, usually they won't ask you to draw anything bigger than the 20th element or calcium because it gets so cumbersome. Hydrogen, 1st row, so in other words, 1 electron shell. And tellurium here, located in the 5th row, should have 1, 2, 3, 4, 5 electron shells or orbits on which to place its electrons. So to recap, periods refer to the rows of the periodic table, and all the elements on a row are basically in the same period, and that says how many orbits you have. Now we're going to move on to groups. Didn't miss the animation there. So we have 1. Okay, so those basically are the number of valence electrons matching the column. If you notice, the middle of the periodic table has been skipped or jumped over. That is because the transitional metals, which start on scandium all the way to zinc, will not be seen. This is a different subgroup. So the ones that are numbered right now are what are called group A, and scandium to zinc, those columns would be actually group B. We're not going to cover or touch group B in this class, so we always have 1A, 2A with the column of beryllium, 3A, 4 all the way to 8A as mentioned here. So organizing the periodic table, if we take a certain example, we're going to take that second column. If you note in the drawings below, second column is group 2A. Those are your elements, and all of these will have 2 valence electrons, or 2 electrons only placed on that outer ring. Oh, there we go, beryllium. So to recap groups, aluminum, for example, located in the 3rd row, which means there's going to be 3 rings around the nucleus, but also in the 3rd column. So we're going to place 3 electrons on that last ring. Those are our valence electrons. If we look at barium, it's located in the 2nd column. So once we determine the number of periods as well, we're going to find 2 electrons on that last ring. Hydrogen, 1st column, 1 valence electron. And tellurium, basically 6th column of the 6A group, right? So 6 valence electrons. And once again, I'll show you how to draw this in the next unit. So to recap with groups, they're referred to as the columns of the periodic table. Any element, basically the group number tells you how many valence electrons it has. Don't forget, we skip over the transitional metals or those that are in the group B. The last of the categories we're going to be looking at are metals, nonmetals, and metalloids. Metals correspond to a specific area of the periodic table that are shown here. So if we take a look at these types of metals, we'll note that metals, usually for the most part, are shiny. Most of them will be solid at room temperature, except for mercury, which right now is on the right-hand side of your screen. Most metals do corrode, in other words, react with the oxygen in the atmosphere to either change color or to rust, depending if it's iron. And usually they will react to acid. In other words, they'll form bubbles and they'll basically be eaten away by acid. So a quick kind of recap on metals. Metals are found to the left of the periodic table, with one exception. Hydrogen is not a metal. It is a non-metal. It's also what's called under the staircase, which we'll see is basically under the metalloids. So some of the characteristics which we just noticed, they're usually shiny, they're solid at room temperature except for mercury, they do react with acids, and then basic metal characteristics such as generally good conductors of heat and electricity, and they are ductile and malleable. Ductile means that you can easily stretch them into a wire, and malleable, you can easily bend them. We're going to look at the opposite end now. We're going to look at the nonmetals. The nonmetals are located in this section of the periodic table. Please note that hydrogen is considered a nonmetal. For nonmetals, most of them are found in the gas form. When one is solid, when it's solid, it can be easily reduced into powder. You'll note also that some of the gases will actually give a different type of color, which is what you see here in a vacuum. So to go over nonmetals, well, they're basically found to the right of the periodic table, and they include hydrogen. It's what's called above the staircase or above the metalloids. And their characteristics are pretty much the opposite of metals. Many are gases at room temperature. If they are solid, they can easily be reduced to powder, and they are very poor conductors of heat and electricity. The final subdivision of the periodic table are metalloids. Metalloids are 7 basic elements found kind of in the middle of the periodic table. This is what is referred to or known as the staircase. Now, your textbooks or other internet resources can place other elements with the metalloids, but these are the 7 that are most commonly seen as metalloids. So let's take a look at what these look like. So we have boron, silicon, germanium, arsenic, antimony, tellurium, polonium. Now, if we take a close look at all of these, we're going to realize that some of them are shiny, some of them are not. They kind of look metallic for most, but others not. And that's the beauty of metalloids, is they share characteristics with the metals and the nonmetals. They're kind of in between. So to recap metalloids, we have specific elements in this category. There are 7 of them. They form a staircase on the periodic table. Their characteristics, they share properties with metals and nonmetals, and those properties depend on the conditions of use. Sometimes they'll be good conductors, sometimes they'll be poor conductors. And so there we go, so their semiconductors are good conductors in certain conditions, bad. To recap metals, nonmetals, and metalloids. Metals are located to the left of the periodic table, except for hydrogen. Metalloids are in the middle of the periodic table. Nonmetals are to the right of the periodic table, including hydrogen. Metals are solid, except mercury, usually shiny, ductile and malleable, often react with acids, and are good conductors of heat and electricity. Metalloids, properties depend on conditions. They are semiconductors. Nonmetals are mostly gases, and they are poor conductors of heat and electricity. Also, don't forget, if they're solid, they can be easily reduced to powder. To review the mini lesson, because right now we are coming to an end of the second mini lesson. Mendeleev organized the periodic table based on the characteristics of the elements. So physical characteristics and chemical characteristics. He did such a good job that he was able to predict and leave space for elements that were not yet discovered. Going back over those key concepts, all elements in the same period or row have the same number of electron shells or orbits, as seen here. This is the second row of the periodic table, or the second period, and you can clearly see there's 2 rings around the nucleus of each of these elements. A group is the column of the periodic table, and that tells us how many valence electrons each element has. In this case, we're looking at the second column of the periodic table, and each of these elements have 2 electrons on the outermost ring around the nucleus. So they are in the second group or the second column. Metals are located to the left, solid except for mercury, shiny, ductile, malleable, often react with acids, and good conductors of heat and electricity. Metalloids in the middle share properties between metals and nonmetals, and the nonmetals to the right, including hydrogen, are mostly gases and poor conductors of heat and electricity. So thank you again for listening to the second mini lesson. In the next mini lesson, we're going to be talking about the groups, and more specifically the families, the 4 major families. So best of luck on the worksheet, and hope that you guys listen on the next mini lesson. Have a good day.